There is a coffee shop that sells 280 kilograms of coffee a year. The coffee beans are purchased from a local supplier for 2.4 shekels or dollars, whatever you want, per kilogram or per pound. The coffee shop estimates that the paperwork and the labor cost of each order is $45, and the inventory holding cost is calculated based on the annual interest rate of 20%. So there is some question we need to answer. So the first question, what is the optimal order size for a coffee? So first of all, let's elaborate on the actual data we know. So there is around 280 pounds or kilograms of demand in a year. So this is from the first. So the second one, we know the cost per unit is 2.4 dollars, and there is the order cost, which is $45. So, and there is here the interest, which is 0.2. That's the same for like the 20%, so it's 0.2. And here we are calculating the holding cost. So this is the interest and this is the holding cost. Holding cost is the interest times the cost per unit plus the maintenance cost. So we get 0.48. Good, right? And because we get 0.48, now we can calculate the first section, which is what is optimal order size. We will remember that the formula is Q optimal is the square root of 2 multiplied by K multiplied by D divided by H, and then we can do equal to, and we get the actual answer, which is around 229.12. So I'll round it down a little bit, so it's 229. And then the second question is, what is the time between successive orders? We can divide Q by D, so we can get the ratio of the time between the orders. So we get 0.818, so it's meaning around every 0.82 year we need to order, which is around every 9.8 months. So it's around 9 months and 8, which is around like 9 months and 20 days. Okay, so then we get for C, which what is the average annual cost of holding inventory and placing coffee orders? So we have a really simple formula for that. So we shall Q equal 2 square root of 2 multiplied by K, D, and H, and then we can just plug it into the formula and we get 109.98, which is around 110. I just rounded up a little bit. And if the delivery time is 3 weeks, what is the optimal reorder points based on the inventory level? So we just need to find when to order the inventory. So this is really easy. So we just calculated the weekly demand, which is 5.38 kilograms. How did I calculate the weekly demand? I just took the yearly demand and divided by 52. So we get the weekly demand. And then we multiply that by 3. Then we get 16.15. And why did I say that we need to order around that? Because this is the point, then we have 3 weeks of demand to run through. So we need to order at that point when we have 16.15. And the last section, they ask us, suppose that the actual cost of placing in a coffee shop order is 15. What is the error made in calculating the annual cost? So what will be the actual adjustments we need to make? Just pay attention, it's really easy. We need to change the K. The K move by a factor of 3 from 45 to 15. So everything will be multiplied by a factor of will be divided by a factor of square root of 3. So we can check that by that, but we just can plug it into the formula and get the actual results for the average annual cost and for the optimal batch size. Hope you liked the video. Please like and subscribe.